Okay, let's take a moment to talk about the controversy of winding styles. Now I'm using a tight winding style for, I think, some really good reasons, and there's some valid concerns about that. One, if you have tight windings, you could potentially saturate the core. That's a concern because you saturate the core and it's not going to transform properly. You're going to create a lot of heat. You're going to be losing function out of it. Now, we're solving that through the use of the 52 material as well as a stack of cores. So there's quite a bit of surface area, or not surface area, but inner area to dissipate that energy. The next one, proximity effect. When you have wires that are really close together and you're running RF through them, the amount of space available for that current to flow gets altered through the proximity effect. Now, we're addressing that with larger gauge wire. The larger gauges not only spaces your wire out just a little bit more, but there's a lot more surface area for the current to flow in. And I think we've done a good job of mitigating the challenges with proximity effect in this design. You might have concerns about leakage induction. Why would you make a tight winding style? To help control that. The further around the core your windings go, the more chance there is for losses. And so we're trying to minimize that. But what about interwinding capacitance? The closer your windings are together, the more chance there is for that interwinding capacitance to wreak havoc. You're right, it's really valid. There's been some really good tests about this. Gary Rondeau had some wonderful examples. KN5L had some really good examples too. Owen Duffy has a lot to say about this. In testing with this design, I tried a bunch of their different styles, and really the one that was best, at least tested most efficiently for me, build after build after build, because oh man, I've done so many, was the tight winding style, just all the way around. Again, using the larger gauge wire, not only are we helping to mitigate the proximity effect, we're helping to mitigate leakage induction with the closed style. We're also going to be reducing ohmic losses. So it's important to use the thicker gauge wire, especially for the primary coil. That's where the majority of the current's going to be, a lot more current than any other part of the transformer. So it's important there too. But I've noticed using the larger gauge wire, like 14 gauge for the secondaries, seems to help with the coupling and seems to help prevent losses higher up in the frequency range. So anyway, so that larger gauge, I think, is the key here for some of the concerns, and ultimately the proof is in the pudding. Now, you might be able to pick apart my testing techniques. Some people don't like the nano VNAs. That's okay. We can at least run the exact same test setup with various winding styles and just compare test after test after test. What do they look like with the same kind of measurements? And in this case, boy, the tighter the windings, the better. So that's the style we're using. Now, one of the problems that we're going to come across is as you wind thick wire on the inside of the toroid, you're going to lose space. I should say you may run out of space for your wires on the outside to be very flush and together, and so it's really tempting to leave little gaps in there. One way that I've found to improve things, let me put this in the camera, is you got your windings that are very nice and tight on the inside, and you see I've gapped them right there. And right now I'm using these little zip ties to hold them together. The zip ties, although they are UV resistant, I don't want to keep them in the final design. These are just to hold them together while building, and then I can put little spots of epoxy there, to hold it in. The epoxy is going to handle higher temperature, and through the use of just a little bit, we shouldn't affect the characteristics of this. But that gap, maintaining the majority of the wires really close together, and just having one gap Or as you start to do like 20 plus windings on there, you're going to have another gap over here, and that's okay. In my testing, this sort of a style had way more efficiency than anything else I've tried, at least for these cores, with this gauge, with this test equipment, and so forth. So anyway, we're going to keep that in mind.